In this video, we're continuing on with our Factoring Trinomials worksheet on the KutaSoftware under the Infinite Algebra 1 section. I'll leave a link in the description below so you know how to access this free worksheet. In this video, I'm going to work through problems numbers 11 through 18. Now, starting with number 11, we have to find two numbers that multiply to give us our C value, which in this case is a negative 56 since that 56 is subtracted, and add to give us our B value, which is a negative 1 since we're subtracting 1 in. So the factors of 56, we have 1 and 56. And remember, this is a negative 56, so one of these numbers will be negative and one will be positive. But adding either 56 as negative or 1 as negative, we will not get negative 1. Then we'll move on to 2 and 28, and that combination will also not equal negative 1. Then 4 and 14, that combination will not give us negative 1, but 7 and 8 will. 7 times 8 gets us a positive 56. So in order to get a negative 56, one of those will be negative. And it will have to be the number that's greater, so the 8 will be negative. Since 7 plus negative 8, or 7 minus 8, will equal negative 1. So we'll do n plus 7 times n minus 8. And that's our factored solution in number 11. And if you want to double check, FOIL this out. Multiply the first terms, the outside terms, the inside terms, and the last terms, and see if you get your original polynomial. In number 12, we're going to see what two numbers multiply to give us 6, but add to give us a negative 5, since C is positive 6 and B is negative 5. And we can assume, since B is negative and C is positive, that the factors will both be negative, since a negative times negative is a positive. So negative 1 plus negative 6 will not give us negative 5. Negative 2 plus negative 3 will indeed give us negative 5. So our numbers will be negative 2 and negative 3. So we'll have n and we're subtracting 2, and then we'll have n and we're subtracting 3. n minus 2 times n minus 3. And number 13, our C value is a positive 8 and our B value is a negative 6. So what two numbers multiply to give us 8 but add to give us negative 6? So we can assume that our factors will both be negative. So negative 1 times negative 8 gives us a positive 8 but does not give us negative 6. Negative 2 and negative 4 gives us a positive 8, and when added together, they indeed give us a negative 6. So we'll have negative 2 and negative 4 as our numbers within our factors. So it'll be minus 2 times b minus 4. And we could also write this as b minus 4 times b minus 2. The order does not matter since multiplication is commutative. In number 14, we have the same numbers except C is positive 8 and B this time is a positive 6, as opposed to a negative 6 like in the previous problem. So our factors are 1 and 8, which do not add to give us 6, but 2 and 4 do add to give us 6. So we're going to do n plus 2 times n plus 4. n plus 2 times n plus 4. And number 15, our a is a 2. However, we want a to equal 1. And in order to do that, I need to pull out a 2 from each of these terms. So as opposed to having 2n squared, I'll do 2 times n squared plus 2 times what will give us 6n. Well, if we were to divide 6 by 2, we would get 3. So 2 times 3n would give us 6n, and then 2 times what will give us 108. If we were to divide 108 by 2, we would get 54. So you can see I did not change the value of this polynomial in number 15. I just pulled out a 2 from each of the terms. Now look, our a is indeed 1, our b value is 3, and our c value is a negative 54. So I need to find two numbers that multiply to give me negative 54, but add to give me a positive 3. And I know off the top of my head that the difference between 6 and 9 is 3, and they multiply to give me 54. So that's going to be a negative 6 since 6 is smaller and we need that b to be positive. So we want the smaller of the factors to be negative. So negative 6 plus 9 does indeed equal 3, and negative 6 times 9 equals negative 54. So we have n minus 6 times n plus 9. However, that was just for the polynomial that was multiplied to 2. So we need to multiply 2 to those factors. When we factor out n minus 6 times n plus 9, we'll get n squared plus 3n minus 54, and then we need to multiply that by 2. So our answer is 2 times n minus 6 times n plus 9. And number 16, again, we're going to need to pull out a number from each of the terms, and that number is going to be 5, since each of these is divisible by 5. So pulling out a 5, we'll have n squared, and then 5 times 2n will give us 10n, and 5 times 4 will give us 20. So if you need to, just write 10 divided by 5, that's equal to 2, and 20 divided by 5 is equal to 4, so that you know what those numbers are. Now looking just at this polynomial, we know that a is 1, b is a positive 2, and c is a positive 4. Writing my factors of 4, I have 1 and 4, and then 2 and 2. However, 1 plus 4 equals 5, which is not 2, and 2 plus 2 equals 4, which is not 2. Therefore, I cannot simplify this any further. So the factored form in number 16 is 5 times n squared plus 2n plus 4. Since n squared plus 2n plus 4 is not factorable. And number 17, again, I'm going to have to pull out a number from each of the terms, and that number this time is 2. So 2 divided by 2 is 1, 22 divided by 2 is 11, and 60 divided by 2 is 30. So when I pull out my 2, that'll be k squared plus 11k plus 30. So now looking at this polynomial, my b is positive 11 and my c is positive 30. So I need to find two numbers that multiply to give me 30 but add to give me 11. Going through the factors in my head, there's 1 and 30, 2 and 15, 3 and 10, and then there's 5 and 6. And 5 plus 6 equals 11. So I'm going to have k plus 5 times k plus 6 for this polynomial, but remember we're multiplying that by 2. So my final solution is 2 times k plus 5 times k plus 6. And lastly in this video, number 18. My a in number 18 is 1, so I don't need to pull out a number from any of my terms. My b is equal to -1 and my c is equal to -90. So I have to think what two numbers multiply to give me a -90 and add to give me a -1. When I split this up into the factors of 90, I know that my smaller number is going to be positive and my larger number is going to be negative, so that the addition between the two will be negative. And I know that 9 and 10, the difference between those two is 1. So my 10 is going to be negative to give me that 9 minus 10 is -1. They multiply to give me -90 and add to give me -1. So I'll have a plus 9 times a minus 10 as my final solution in number 18. And remember, the order in which we multiply those polynomials doesn't matter, so you could also write a minus 10 before a plus 9. If you found this video helpful, click that subscribe button, and while you're clicking that, go ahead and give me a thumbs up. Also, if you have any questions, leave a comment below, and I or one of your peers will get back to you as soon as possible. Feel free to pass this video along and share it with your friends. And continue on to the next video, where I'll finish this worksheet, completing numbers 19 through 26.